Hey everyone! Today we are diving into improper integrals. These can look a bit intimidating because they involve infinity, or points where the function blows up. But once you learn the limit trick, they are just like normal integration. We are going to solve these two specific problems step by step. If an integral doesn't settle on a finite number, we say it diverges. And for this exercise, we will mark those as 9, 9, 9. Let's start. First, let's look at problem A. We are integrating from 1 all the way to infinity. Before we integrate, let's rewrite the expression so it is easier to work with. We can change the fifth root of x to x to the power of 1/5. Since it is in the denominator, it becomes x to the power of negative 1/5. Now, because one of our limits is infinity, we officially need to write this as a limit. Let's replace infinity with a variable, like a, and let a approach infinity. Now we apply the power rule. Add 1 to the exponent and divide by the new exponent. So x to the power of negative 1/5 becomes 5 over 4, x to the power of 4 over 5. Now multiply 15 by 5 over 4, x to the power of 4 over 5. This simplifies to 75 over 4, x to the power of 4 over 5, evaluated from 1 to a. When we substitute an a and let it go to infinity, a to the power of 4 over 5 just keeps getting bigger and bigger. It never stops. Since the result is infinity, the integral diverges. Following our instructions, we will enter 9, 9, 9. Now for part B. Notice the limits are 0 to 1. The issue here isn't infinity. It is that we can't divide by 0. This is an improper integral, because the function is undefined at x equals 0. Just like before, let's rewrite the function and use a limit to approach 0 from the right, since we are only interested in the values of x that are inside the interval, 0 to 1. To get from 0 to 1, you must move in the positive direction, which is the right direction. Again, we use the power rule to integrate our function, so x to the power of negative 1 over 5 becomes 5 over 4, x to the power of 4 over 5. Let us multiply the integration by our constant 8. This simplifies to 10 times x to the power of 4 over 5, evaluated from a to 1. Now we evaluate from a to 1. As a approaches 0, that second term becomes 0, so we are left with just 10 times 1, which is 10. Because we got a real finite number, this integral converges to 10. To recap, in part A, the exponent was less than 1 while going to infinity, so the area kept growing forever. Therefore, the answer was 9, 9, 9, because it diverges. For part B, we were looking at the area near a vertical asymptote. Because the gap closed fast enough, we got a finite area, so our answer is 10. If you found this video helpful, hit that like button and subscribe for more math tutorials.